Okay, here we are trying to get this word problem focused. There we go. So super word problem, let's just read together. You can take panoramic photographs using a hyperbolic mirror. Light rays heading toward the focus behind the mirror are reflected to a camera positioned at the other focus. After a photograph is taken, computers can unwrap the distorted image. Write an equation for the cross-section of the mirror if the distance to one vertex is 3 centimeters and the distance to the focus is 4 centimeters. Assume the camera is being held perpendicular to the ground to take a picture. Okay, so the camera is being held perpendicular to the ground. So what that's kind of telling us is that that transversal axis is perpendicular to the ground. So that's telling us that this hyperbola that we're going to be dealing with is opening up and down. Okay, that's important for us. Then we also are given information that one vertex is 3 centimeters from the center. So the vertex is your A value. So that's telling me that A is 3, which means that A squared is 9. And that's in the y direction because my hyperbola is opening in that y direction. So I can put a little y there. And then I know that C is 4 because right here it tells me that the focus is 4 centimeters away. So that means that C squared is 16. So we can now plug that into our foci formula, figure out what B squared is. So A squared, 9, plus B squared equals C squared, which is 16. So that's going to tell us that B squared is 7. Now, because A is already matched up with Y, that means that B has to match up with X. We're going to assume that the center is at the origin. It doesn't tell us anything different, so when you're doing word problems, that's kind of a safe assumption to make. So fraction minus a fraction equals 1. And then we're going to go ahead and say that Y is first because my A value of 9 is first. And we match those up. And then my B value is second with my X value. And there we go. You guys are masters. Don't forget to do your quick check.